let me start with the new chapter, hydrogen. Start with the hydrogen. In the 10th standard, we have studied that hydrogen is the most abundant element in the universe. Hydrogen is the most abundant element. Most abundant element in the universe. Abundant element in the universe. Why do we say in the universe? As you know, the stars consist of hydrogen gas. Hydrogen. That's why we say hydrogen is the most abundant element in the universe. In Earth, the uncombined form of hydrogen is found to be only a very small extent in the free state. But in the combined state, it is seen to a large extent as water and hydrated salts also. In the gaseous state or in the elemental state, hydrogen exists as diatomic molecule. Hydrogen exists as diatomic molecule. Diatomic molecule. What is the meaning of that? In a molecule of hydrogen, there are two atoms, and we call it as dihydrogen. Molecular hydrogen is named as dihydrogen. Oxygen is also diatomic, nitrogen diatomic. You take the noble gases. In the noble gases, in the molecule, there will be only one atom in the molecule. That means the atom and the molecule of a noble gas will be the same. And they are called monoatomic molecules. Noble gases are known as monoatomic molecules because in the molecule of a noble gas, there will be only one atom. As I told, atom and the molecule will be the same. The number of atoms per molecule, that's called atomicity. The number of atoms per molecule, that's called atomicity. If it is so, atomicity of hydrogen is equal to 2. It is diatomic. There are two atoms. There are two atoms in a molecule of hydrogen, and therefore the atomicity of a hydrogen, that is equal to 2. You take ozone, O3 molecule, O3 molecule. In a molecule of ozone, there are 3 oxygen atoms, and therefore atomicity of ozone, that is equal to 3. That is equal to 3. Similarly, you take, say, ammonia, NH3. In a molecule, there is 1 nitrogen and 3 hydrogen atoms, totally 4. Atomicity is equal to 4. So in general, atomicity is the number of atoms present in the molecule. You take the case of the elements, say hydrogen is an element, and in the elemental form, in the gaseous form, it is a diatomic molecule, H2, and it is called dihydrogen. So hydrogen is a renewable source of energy. We know hydrogen economy. So it is used as say source of energy, renewable source, because without any pollution, we can use hydrogen as a source of energy. When hydrogen burns, only water will be formed. So there is no problem of environmental pollution, and a large amount of energy will be released, especially heat energy will be released. So it is used as a source of energy. And we treat it as a renewable source, renewable. Why is it called the renewable source? Because when hydrogen burns, water is formed, we get the heat energy, then water can be decomposed electrolyzed to give hydrogen, and that hydrogen can be used again. That's why we say it is a renewable source of energy. So hydrogen economy is very important. There is no pollution, and we can use the product of burning combustion of hydrogen. Water can be used again for the production of hydrogen, and so it is a renewable source of energy. So hydrogen is the most abundant element in the universe. It exists as a diatomic molecule H2 in the molecular state and in the elemental state, and it is called a dihydrogen. Hydrogen is used as a renewable source of energy. Okay, that is point number one we have to see in the chapter hydrogen. Now you come to the position of hydrogen. Position of hydrogen in the periodic table. Hydrogen in the periodic table. That also you studied in the 10th standard, which is the position of hydrogen in the periodic table. Before going to the position, let us consider the electronic configuration of hydrogen. As you know, atomic number of hydrogen is equal to 1. Is equal to 1. There is only one electron. Now you arrange this electron according to the oboe principle. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. That is the oboe order. Here we have only one electron, and that single electron will be in the 1s level. 1s level. And we write it as 1s1. That's the electronic configuration of a hydrogen. Hydrogen atom, atomic number is equal to 1, and 1s1. That's the electronic configuration of a hydrogen that we have already studied in the chapter atomic structure. Michael, do you hear me or not? Okay, so it is 1s1, the electronic configuration. Now, the nearest inert gas, the noble gas of hydrogen, that is helium. The nearest noble gas, that is helium. That's atomic number 2, and the electronic configuration is equal to 1s2. So when hydrogen combines with the other elements, it has a tendency to get the electronic configuration of the nearest noble gas, helium, 1s2. That means 2 electrons in the valence shell, in the outermost shell, 2 electrons. So here is a tendency to complete the doublet, the duplet, 2 electrons, just like the nearest noble gas, helium, so as to attain stability, the stable configuration. Now, so hydrogen has the tendency to accept 1 electron to get the configuration of helium with the 2 electrons in the outermost level. At the same time, hydrogen has a tendency to lose electron. There is only 1 electron. Valence is equal to 1. Valence electron is equal to 1. And that single valence electron can be lost from hydrogen atom. And it is the tendency of the alkali metals, lithium, sodium, potassium, etc. So we know that hydrogen has similarity with the alkali metals group 1 and halogens group 17. Group 1, tendency to lose 1 electron to form +1 ion, unipositive ion. Na plus 1, Li plus 1, then K plus 1, etc. Similarly, hydrogen also, it gives H plus 1. H plus 1 is our proton. So our proton, or it is the hydrogen ion proton. Hydrogen ion proton, H plus 1. So it shows a similarity with the alkali metals. Say group 1, alkali metals. Lithium, sodium, potassium, rubidium, cesium, etc. To lose 1 electron with the formation of a unipositive ion. that is a plus one ion. At the same time, just like the group 17, which is a group 17, do you remember or not? They are halogens. Halogens. Halogens, say in halogens, in the outermost level, group 17, fluorine, chlorine, bromine, iodine, statin, etc. These are the halogens. Fluorine, chlorine, bromine, iodine, statin is radioactive, and some missing element also, we just leave it. So you think of only fluorine, chlorine, bromine, and iodine. So in all these, there are seven electrons. There are seven electrons in the valence shell. Seven electrons. And to complete the octet, 18 electrons, it will become 18 if it gets one electron. And that's the configuration of the nearest noble gas, that is argon. Argon. So hydrogen resembles, hydrogen shows similarities with the alkali metals group 1, lithium, sodium, potassium, etc. And the halogens group 17. Group 17, there's a tendency to accept one electron. Okay. So due to the similarity with the alkali metals and halogens, where should hydrogen be placed? The position of hydrogen, that still remains questionable. But as we know, hydrogen is the first element. Atomic number is equal to 1. Atomic number is equal to 1. And it is the lightest element. Atomic mass is equal to 1.008 or a 1U. 1U. The element with the atomic number is equal to 1, and the lightest element, say mass is equal to, atomic mass is equal to 1U, unified mass. So it is the lightest element also. And so hydrogen is kept above the alkali metals. In the first group, above the alkali metals, it is kept in a separate box. Say we have group 1 alkali metals like this, say lithium, sodium, then potassium, rubidium, then cesium and francium. Above this, in a separate box, hydrogen is kept because it is not added to the alkali metals, but being the first member with atomic number is equal to 1 and the lightest element, it is kept in the first place itself. The first place, the position number 1 is given to hydrogen, and that is kept in a separate box, above the alkali metals. That's about the position of hydrogen in the periodic table. And this problem arises due to the similarity of hydrogen with alkali metals as well as halogens. Okay. Now you consider the isotopes of hydrogen. Isotopes of hydrogen. Let me ask you, what are isotopes? What are isotopes? As you know, isotopes are, they are atoms with the same atomic number. Forgotten? Same atomic number. Same atomic number, but different mass numbers. These are the atoms, different mass numbers, different mass numbers. So these are the atoms of the same element, same atomic number. Same atomic number means same element. So these are the atoms of different atoms of the same element with the different masses, with the different masses. So isotopes have same atomic number but different mass numbers. Do you remember the important isotopes of hydrogen? Do you remember? There are three isotopes. I think that we have seen that in the atomic, the first chapter we have seen that. Okay, I shall repeat it. The isotopes of hydrogen are one. Protium, remember now? Say protium, it is a H11. That is the symbol. The symbol is a H11. Protium, protium, H11. Then second is a deuterium, 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 deuterium. It is also known as heavy hydrogen. Deuterium or a heavy hydrogen. Deuterium or a heavy hydrogen. And the symbol is H12 or deuterium capital D. Capital D. H12 or D. Deuterium heavy hydrogen. And the third one, that is our tritium. It is a tritium. Tritium, that is a H13. H13. Or it is say symbolized as capital T also. So these are the three isotopes of hydrogen. Protium, H11, deuterium or a heavy hydrogen, H12 or capital D, and tritium, H13 or capital T. Among these, tritium, that is a radioactive element. Tritium is a radioactive. It is a radioactive. It shows a radioactivity. So the question will be, say, what is protium? Protium is the lightest isotope of hydrogen with mass number 1. What is heavy hydrogen? It is the heavy isotope of hydrogen, namely deuterium with a mass number 2. What is tritium? It is the heaviest isotope of hydrogen with a mass number 3. Another possible question. Among the various isotopes of hydrogen, which is the radioactive isotope? The radioactive isotope of hydrogen is tritium. Tritium H13, and it is a beta emitter. You know, in radioactivity, you might have studied. During radioactivity, three types of radiations are emitted from the nucleus of atoms. Have you studied radioactivity? Have you studied it not? Studied? No, there are certain heavy metals like uranium, thorium, and neptunium, etc. For example, like uranium and the nuclei of this is nucleus. In nucleus, there is proton and neutron, and these are highly unstable. Nucleus, sir, nucleus of heavy atoms like uranium, for example, uranium 235 or uranium 239, etc. Okay, so these are the nuclei of heavy atoms, highly unstable, and there is spontaneous disintegration. The nucleus has a spontaneous disintegration by emitting some mysterious radiations, some invisible radiations from the nuclei of heavy metals like uranium, say, radium, etc. Uranium, radium, thorium, etc. They emit mysterious radiations from the nuclei, not from the not from the atomic shell, not from the orbit, not from the orbit. This is not a chemical change. This is not a chemical change. This is called a nuclear change. It's a nuclear change. The change is for the nucleus. The nucleus is highly unstable and it splits. The nucleus splits. It decomposes, forming smaller nuclei. Smaller nuclei. Say uranium 235. It splits into almost equally, say, weighing two parts will be formed. So there is the fission. The fission of a fission means a bifurcation, splitting of the nuclei with the emission of some mysterious radiations. And that property is called radioactivity. So radioactivity is the disintegration, especially the spontaneous disintegration of atomic nuclei. Atomic nuclei, repeat, atomic nuclei with the emission of some kind of mysterious energy radiations. And the property is called radioactivity. Henry Becquerel, you will study this more in physics. In physics, second year, I think, there is modern physics. It's a very simple chapter. In the modern physics, all these things will be coming there. And there is the emission of the radiations from the nuclei. And these radiations coming from the nuclei, they are invisible, and they are the radioactive rays. They are called radioactive rays. The process is called radioactivity, emission of a radiation, radioactivity from the nucleus. The nucleus is split. It is bifurcated, that is decomposed. At the same, new nuclei will be formed up. New stable nuclei will be formed up. When new stable nuclei are formed, there will be other atoms. The parent atom that is converted to other atoms, and they are called the daughter products. Daughter, parent and the daughter. The nucleus of the parent splits, giving new atoms called the daughter atoms. Daughter, not the son atoms. They are called daughter atoms. I don't know why they are called daughter atoms. So probably they can show radioactivity again. They can show radioactivity again. That may be the reason. They are called a daughter. Daughter, they are also productive. That may be the reason. So they are called the daughter atoms, the daughter products. And during this process, invisible radiations are given out, and these are called the radioactive rays. In the radioactive rays, there are three types of radiations. There are three types of radiations. They are alpha, beta, and gamma radiations. There are three types of radiations: alpha, beta, and gamma. Don't think that all these three types of radiations are emitted from the nucleus of the same atom at the same time. At the same time. At one time, say only the one type of rays will be coming out. For example, alpha rays are coming out, or beta rays are coming out, or gamma rays are coming out. See, it is not compulsory that all the three types of radiations will be coming out from the nucleus at the same time. Same time. No, there may be alpha or there may be beta emission. And after alpha or beta emission, the excess energy is given out, and the excess energy is gamma rays. That is gamma rays. That is energy radiations. While alpha and beta, alpha, that is, alpha rays are the nuclei of helium. They are the nuclei of helium. While beta rays are composed of electrons. They are electrons. Beta rays are composed of electrons. Gamma rays are simply electromagnetic radiations, energy radiations. Okay, so here, tritium, you come to tritium. More details you study in physics in second year. Okay, so here, tritium is a radioactive, and it is a beta emitter. Beta emitter. That means beta radiations are coming out. Beta radiations means electrons. Electrons are coming up from the nucleus of a tritium, from the nucleus of the tritium atom, tritium isotope. Beta radiations, electrons are given out. We know electrons are not there in the nucleus. Which is the position of an electron? That is outside the nucleus. No, is it not? Position of electron outside the nucleus, in the orbits, in the orbitals, not in the nucleus. But during beta emission, electrons are coming out from the nucleus. How? Some changes are taking place there, and the change is for neutron. The change is for neutron. A neutron splits, say during beta emission, during beta emission, a neutron, a neutron splits into a proton and an electron. Proton and an electron. And this electron is given out as a beta ray. And the proton remains in the nucleus. So the number of proton in the nucleus increases during beta emission. Since the number of proton increases, the atomic number increases during beta emission. And we are not supposed to study more details. Let me stop it here now regarding radioactivity. So come back to the isotopes of hydrogen. They are protium H11, deuterium or a heavy hydrogen H12 or a D, and tritium H13 or a capital T. Among these, tritium is the radioactive isotope of a hydrogen. It is a beta emitter. Beta means electrons. Beta rays means electrons. They are coming from the nucleus. When electrons are emitted from the nucleus, a neutron is split into proton and electron is emitted as a the new electron is emitted as the beta ray and the proton remains in the nucleus. Okay, that is enough for the time being, I think. Now let us see the structure of a protium, deuterium, and tritium. The structure of a protium, deuterium, and tritium. Let me take protium. Protium. You know, protium is H11. H11. What is the meaning of this? H is the symbol. H is the symbol. Okay, hydrogen. And what is written at the left hand bottom corner? The left hand bottom corner. That is the atomic number. What is written at the left hand bottom corner? That is the atomic number. What is written at the right hand or left hand top corner? That is the mass number. Mass number. So at the top, there is mass number. What is mass number, Michael? Mass number. That is the sum of protons and neutrons. Mass number is equal to, remember, A is equal to number of protons, Z, atomic number, plus number of neutrons, N. Total number of protons and neutrons, that is mass number. And that is written at the top. What is written at the bottom? And that is the atomic number. Atomic number means number of protons. If you get number of protons, from that we'll get the number of electrons also. The second one, what second one? That is deuterium or deuterium or heavy hydrogen H12 or a capital D. And the third one, tritium. Tritium H13. Tritium H13 or a capital T. Let us see the structure. Structure means how many protons are there, how many electrons are there, how many neutrons are there, what is the mass of an atom, mass of an isotope. That is what is meant by the structure. Let us take one by one. Say atomic number of a protium is equal to 1. So what will be the number of protons, Michael? Atomic number is equal to 1. Number of protons. Sunny, you please come. You open your mouth. What is atomic number? Gayatri, please help him. Please help him. What is atomic number?
Number of protons.
Number of protons. It is the same number of electrons also. So if you get the atomic, Michael, if you get the atomic number, from that you will get the number of protons as well as number of electrons. All right. So right, P is equal to 1, then electrons, that is equal to 1. And what will be the number of neutrons? Number of neutrons. How do you get the number of neutrons? To get the number of neutrons, you check the mass number. Mass number, what is written at the top? Mass number. Say at the mass number. What is mass number, Michael? Mass number. Proton plus neutron. Proton plus neutron. So from that you subtract. From the mass number, you subtract the number of protons. That will be the number of neutrons. If it is so, how many neutrons are there in protium isotope? Come on, Michael, say. Pardon? I did not hear you. Gayatri, what he said?
I can't hear him, sir.
Oh, not audible. You just unmute and say, Michael. So, number Gayatri, what is your opinion? How many?
0.
So, neutron is equal to zero. Neutron is equal to zero. And now you take the mass, atomic mass is equal to, atomic mass is equal to 1.008 U, approximately equal to 1 U. That is fraction. Okay. Now you come to deuterium or a heavy hydrogen. Deuterium or a heavy hydrogen. Here P is equal to Acho,
1, sir.
of course equal to 1. Electron is equal to
1.
1. Then neutron is equal to
2 minus 1. 1.
1 is equal to 1. And atomic mass. Atomic mass is equal to, say,
Same, sir.
you not zero. Atomic mass. Say 1 proton and 1 neutron. Proton 1, neutron also is equal to 1 approximately. And so the total will be 2.0404 U or 004 or 014. You just remember 2U, double 2U. Proton is equal to 1, mass is equal to 1U, neutron is equal to 1, mass is equal to 1U, approximate mass. So that is equal to 2. Then come to tritium, P is equal to 1, electron is equal to 1, and the neutron is equal to 3 minus 1 is equal to 2. So atomic mass will be 3 times. 2 neutrons and 1 proton. That is equal to 3.0016 U or approximately 3. You compare this, atomic mass. See here, atomic mass. Similarly here 2, here mass. See this one, atomic mass. See, comparison. The last digits are neglected. It's a negligible amount. Negligibly small amount. So it is almost the same as the mass number given. Atomic mass is the same as the mass number given. Okay. If it is so, you name an atom which does not contain neutron. Michael, not audible. Okay, Achu, an atom,
Protium, sir.
protium. Protium is the only atom. Protium is the only atom. Michael, can you hear me? Can you hear me? Michael, can you hear me? Huh?
Yes, sir.
It's all right. It's all right.
Yes.
So, uh, protium is the only atom. The only atom among all the atoms, all the elements. Protium is the only atom which does not contain neutron. Say neutron free atom, that is protium. That is the lightest isotope of hydrogen, and it is known as ordinary hydrogen. Ordinary hydrogen. Okay. So that's about the isotopes. Now let us think of hydrides. 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 What are hydrides? You know, hydrides are, okay, what are oxides? What are oxides? Oxides contain oxygen atom. Oxygen atom. Magnesium oxide, MgO, calcium oxide, CaO, aluminum oxide, Al2O3. Okay. So carbon dioxide, CO2, carbon monoxide, CO, there is oxygen. So oxides are binary compounds of oxygen. Similarly, hydrides are binary compounds of hydrogen. Binary, binary compounds, binary compounds of hydrogen. Hydrides are binary compounds of hydrogen. What is meant by binary compound? Binary compound. What is the meaning of a binary compound? A compound which consists of only two types of elements. There are only two types, of elements. Only two types of elements. Only two types of elements. After this, one is hydrogen. Binary compound of a hydrogen. Binary compound. In binary compound, say A plus B giving AB. Suppose AB is a binary compound. AB is a binary compound. In AB, there are only two types of atoms, or A plus 2B giving AB2. AB2, that is also a binary compound. There are only two types of, not two atoms, two types, only two types of atoms, two types of elements. They are binary compounds. So here, binary compound hydrogen means one is hydrogen and the other is any other element. An element other than hydrogen. An element other than hydrogen. And they are called binary compounds. So hydrides are binary compounds of hydrogen. So an element plus hydrogen giving the hydride. For example, you take NaH, Na plus H minus, or CaH2, calcium hydride. First compound, sodium hydride. Only two types of elements are there, sodium and hydrogen. Take a calcium hydride. Only two types of elements are there, calcium and hydrogen. Or you take same CH4, methane, CH4. One is hydrogen, other is carbon. Only two types of elements are there. Or you take C2H6, ethane, ethane. It's a binary compound of hydrogen because one is hydrogen, other is carbon. Only two elements are there. Binary compound. All these are hydrides. Or you take H2O, water, or SCl, hydrogen chloride. These are also binary compounds of hydrogen. Because in water, hydrogen and oxygen. In SCl, hydrogen and chlorine. Two elements are there. So such binary compounds of hydrogen are called hydrides. Hydrides. Say, I have written NaH, then H4, then H2O, H2O. Okay. Now let us see the details, more details about hydrides in the coming class. You have sufficient time. It is time now. Let me stop. Thank you.
Thank you, sir.